Good morning, Martin.
Hello.
Hello. We
Hello.
just wait
It is
for
good
yeah.
afternoon.
Yes, yes. We
Yes,
just
it is good
wait for
afternoon.
few
Yes,
minutes. Okay, then we'll
I
start
can.
with
Yes,
those new. We'll start with those numericals, right?
you're right. But now, before we start,
Huh?
I have a request. I missed the first 2 days lessons. Can you forward for me those lessons on my email? Because even other people asking, I don't know whether they did get
I
also.
have forwarded all the lectures to you.
No, don't forward it was voice, right?
I have forwarded all the lectures, Martin. First two lectures also I have
Madam,
forwarded.
from Monday. Okay, thank you. Okay, then, thank you. I'll check everything. Thank you.
Okay, okay. Yes, Martin, did you practice from the yesterday's file numericals?
I can't hear you.
Did you practice numericals from the file that I sent you yesterday?
Yesterday, I was using
Can't hear you. Your voice is breaking.
a phone, but now I'm going to get my laptop back with me. So I know by next day, evening session, I
Your voice is breaking. I can't get you.
will have everything. So what I'm going to download it after. Today I'm going to download it. I said I'm going to download today because yesterday I was using my phone.
That's fine, but this is your theory class. Fine, fine.
But by
I'm
evening,
asking, did you practice the numericals, that number system that we were doing yesterday? Conversion from
yeah,
binary to decimal and all conversions. That I'm asking. Number conversion. Yes, Francis? Yes. Yes, I'm asking, Francis, did you practice the numericals?
Yeah, I tried, but they are a little bit disturbing me. They are disturbing me. Like I can't understand them well.
Okay, anyways, so if you both are clear with those numericals that we did yesterday, so then I can take up the next topic. That's what I'm asking. Yes, what we did yesterday from binary to decimal, octal, and hexa. And then we did how to convert from binary, octal, and hexa to decimal. Okay, and how to convert from decimal to binary, octal, and hexa. Is it clear? From decimal to, okay,
yes,
from decimal
yes,
to convert decimal, from
okay,
decimal to binary, octal, and hexa, and
okay,
from binary, octal, and hexa how to convert it
yes,
into decimal. This we did yesterday, right? Now what we are going to do
yes,
today, yesterday we did how to convert these numbers from one number base to another base, right? Number base system.
yes,
Now today I'll
yes,
teach you how we can convert the fractional number, decimal number. In decimal, we write
yeah,
175.25, right? In decimal number system, in our number system, we use in decimals also, right? To how to convert, if my decimal number is given in fractional, then how to convert that fractional decimal number into binary, octal, and hexa. Okay, right? So how to do that for the fractional part, this I am telling you. Okay, what we will do, suppose if this number is given 0.2345. Okay, so what I'll do, if I have to convert from decimal to binary, what I do, from decimal to binary, what I do, this is my decimal and this is my binary, so I keep dividing it by 2. Okay, 25 is decimal. I'll keep dividing it by 2. I'll write down the remainders, and this will be my conversion from decimal to binary, right? But if my decimal number is in fractional, okay, then what I will do, I will not divide it, I will multiply it with 2, because I have to convert it into binary. Okay, so I will multiply it by 2, then I'll write here, then again multiply it by 2, then write it, then again multiply. Whatever answer you get, keep multiplying it by 2 unless you get 1.0, unless you get 0 after decimal point. Okay, till then you have to keep multiplying it, and when you get 0 after this point, decimal point, then what you have to do, you have to write these integer numbers, not the fractional number, these integers number. Okay, here what we were doing, we were writing it from bottom to top, but here in fractional number we will not write it from bottom to top, we will write it from top to bottom. So how I will write it, 0 0 1 1 1 1. This is the binary conversion of this fractional decimal number. Keep multiplying it by 2 unless you get 1.0, unless you get 0 after point. Okay, and then write this digits in the non-fractional part, not in this fractional part. Digits, integer numbers. Okay, non-fractional part, 0 0 1 1 1 from top to bottom. Is it clear, both of you?
Yeah.
Okay, now see the next, what we have now. Now we have seen how to convert from decimal to binary, octal and hexa. And we have seen how to convert from binary, octal, hexa to decimal. Okay. Now different type of question can come in your exam. Not in decimal, but how to convert from one non-decimal number to another non-decimal number system. Means you may be given convert from binary to octal, or convert from octal to hexa, or convert from hexa to octal, from other base system to non-decimal, not decimal. Till now we were doing decimal to other base system and from other base system to decimal, but now we have to do from one non-decimal number system to another non-decimal number system. My question is clear? Yes.
Yes, yes.
Right. Now, how to do that? If I have to convert from what is given, this octal number is given. How I know that this is octal number? How I will come to know that this is octal number? Yes, Francis. How I will come to know that this 25 is decimal number or octal number? Yes, Francis.
Oct number has nine. Has goes to up to base 9,
8 is written. Where
and
is 9?
and and decimal goes up to 10.
No, what is the difference, Francis? Here in the base 8 is written. Can't you see this? Here in the base 8 is written. That means this is an octal number. When 10 is written as a base, that means this is decimal number. Am I clear?
Yes, please.
So whichever number system is this, we write that number as a base. Okay. If 8 is written as a base, that means this 25 is which number system? Yes, tell me. If 8 is written here as a base, that means that 25 is which number system?
It's octo number system.
Yes, why you are taking so long? Octal number system. Now I have to convert this octal to binary. Okay. Now there are two ways. One is first I will convert this octal to decimal, and then I will convert this decimal to binary. Right. So that you have to do two conversions for this. One method is this. First convert this into decimal that we have done yesterday. Okay. This decimal, and then from this decimal to binary, just like I showed you, divide it by 2 and keep writing the remainders. Second shortcut method. For this, I have to convert it twice. First from binary to decimal, from octal to decimal and decimal to binary. Two conversions I have to do. What is the shortcut way if I have to convert this binary to octal? What is the shortcut way? There is one shortcut way also. Hello, Anji sir. Yes, why you guys join so late? Norbert, Peace, Abdullahi, why you join so late?
Oh, I'm sorry, I'm traveling somewhere, but I'm just trying, but as well I'm traveling, so the network is some
No, no,
somehow.
no,
Sorry.
no. Martin, you joined on time. I'm asking Norbert, Peace, and Abdullahi, why you join so late? All of you should join in time, okay?
Okay. Well, thank you.
Yes, sorry guys. I had a call. Right. So okay. So what I was saying, that this is I was telling you the shortcut. Okay, how to convert from binary to octal. Yesterday we were doing how to convert from non-decimal number, binary, octal, and hexa to decimal, and how to convert from decimal to binary, octal, and hexa. Okay, non-decimal number system. Now, this today I'm telling you how to convert from one non-decimal number system to another non-decimal system. Okay, one topic we have already done, that is how to convert fractional number system. Those who joined late, okay, I'm telling repeating for them that I have completed one, how to convert fractional numbers. Yesterday we were doing how to convert full integers number, okay, without fractions. Now this is the second topic we are doing. What is the shortcut? So as I said, from binary to octal there are two methods. One is first convert from binary to decimal, that we did yesterday, and then from decimal to octal, binary to decimal, and then decimal to octal. Okay, so here you will have to do this conversion twice, right? And there is one shortcut also for binary to octal. What is that shortcut? Suppose if this binary is given, okay, here this base is written as 2, that means this is binary number system. This binary, what I will do, from right hand side I will divide it in a group of 3 digits from right to left. So first is 101, second is 01. There is no third unit, so I can add 0. Okay, if this is 0 before any number, that does not add any value here. So I will convert in a group of 3 from right hand side. Then what I will do, 101 is the binary of 5. Okay, and 10 is the binary of 2. Now how we get this, that this is the binary of 5 and this is the binary of 2? You have any idea? I just show you one table. First I go back, explain you this topic, then I will move further. See, this is 0. For 0, binary is 0. For 1, binary is 1. For 2, binary is 10. How we get this 10? This I am telling you. Here I have given you this table. For 3, this is 1 1. Okay, how we get this? Just see. For this first one, this 1 is multiplied by 2 raised to power 0, right? So that means 1 into any number power 0 is, any number multiplied by power 0 is 1. So 1 into 1, this is 1. Okay, next here, okay, suppose this value of this 1 is 1. Next here, if you have, suppose here if you have 1, okay, just a second. Yes, suppose here if you have 1, this will be 1 into 2 raised to power 1. That means 1 into 2 raised to power 1 is 2. So what it will give you? What it will give you? Just a second. 2 plus 1, that is equal to 3. If this is 1 and 1, that means this 1 will be multiplied by 2 raised to power 0. Just a second, I'm just writing it again. Okay, if this one is multiplied by 2 raised to power 0, this value is 1. If this one is multiplied by 2 raised to power 1, this value is 2. So that means this will give you 3. So that is why I have written for 3, these two numbers value should be 1. If you just want 1, okay, If you just want 1, so that means only this first number should be 1. Then it can be 0 also. Okay. How I got this? Because I know that this number, first number from the right hand side, will be multiplied by 2 raised to power 0, and then it will give you 2 raised to power 0 is 1. 1 into 1 will give you 1. So that means if I write 1, that means is equal to, that means this is the binary of decimal 1. Okay. Here if I have to give 2, what will be the binary of 2? That means here for 2, this 2 into 1 should position. This position should be 1. That means this should be 1 and 0. Because this 0 will be multiplied by 2 raised to power 0, 0 will be 0, and this will be multiplied by 2 raised to power 1. So this will give you 2. If you want 3, so then what I have to do? 1 plus 1. That means this also should be 1 and this also should be 1. 1 plus 1 will give you the decimal value of 3. Because this 1 will be multiplied by 2 raised to power 0, it will give you 1, and this one will be multiplied by 2 raised to power 1. So 2 1 the 2 plus 1 3. So it is the binary of 3. If you have to give 4, that means 2 raised to power 2. This position should be 1. 2 to the 4. So this position should be 1. These both positions should be 0. So what will be the binary for 4? This will be 1 0 0. That means this position 2 raised to power 0 will be 0, 2 raised to power 1 will be 0, 2 raised to power 2, 2 to the 4, this position will give you 4. If you have to solve 5, so that means this 4 plus this position, because this gives you 1, 1 into 1. So these two positions should be 1. Then it will give you 5. Like this we calculate. For 6, what should be the number for 6? 4 and 2. So that means this position gives me 4 and this position, no, 2 raised to power 1. 2 1 the 2. So this second position should be 1 and then it will give me 6. This will give me 0, this will give me 2, this will give me 4. So 4 plus 2, 6. This is how we find out. For 7, 4 plus 2, 6 plus 1, 7. So that means here also I want all these 3 positions. This will give you 0, this will give you 1, this will give you 4. Okay, so this is how we find out. So this table I have written like that, so that if you do some practice after that, this binary conversion will, you can memorize these binary numbers easily. Okay, then you don't need to calculate it for 2, for 4, for 6 after some practice. After some practice, right? So here, like that, what we have to do in this, so we know that 101 is the binary of 5 and 010 is the binary of 2. How? Because this position 2 raised to power 1 will give me 2, so I have to make this second position 1. And how I will get 5? 4 plus 1. So this number will give me 4, because this will be multiplied by 2 raised to power 2, and this will be give me 1, because this will be multiplied by 2 raised to power 0. So this will give me 4 plus 1, 5. Okay, so what you have to do, you have to simply divide this binary number into group of 3 for octal. You have to divide in group of 3 from right hand side, and then write the binary number for this group and write the binary number for this group. So this you will get 25 in octal. This is the shortcut for converting binary into octal. Is it clear? Oh, my sharing has stopped. My screen is not visible. Am I audible? So you should have told me why you were not. I mean, I need to repeat this. I don't know how it get disconnected. That's okay, Martin, but I don't know. I mean, I just repeated the logic. You couldn't see it. I don't know. Just a second. This I was writing down all the calculation. This you could see how I get 4, 5, and 6 and 7. Yes.
We didn't see anything.
You should have interrupted me that time only. Okay, I'll repeat it. See what I'm saying? If only this 1 is there, first number 1. Okay. So here, this is 1 is a binary number for decimal 1. Why? Because this one position, 0 power of any number gives you 1. Okay, so this 1 into 1 will give you 1. If you have to write what is a binary conversion for decimal 1, how you will write it. Now if you have to write for 2, now what do you want for 2? You want that 2 raised to power 1. 2 raised to power 1 is 2. So if this position is 1, 1 into 2, so this will give you the binary conversion for decimal number 2. If I have to write 2 in binary, so what I will write, this number should be 1 because this will be multiplied by 2, and then this number should be 0 because then it will give you 0. So this 1 and 0 if you write, so this will give you 2 in decimal. Okay. Suppose if you have to write for 3, what will be the binary for 3? What I'm telling you that this is the table I have already given. For decimal 0, you have to write this binary. For decimal 1, you have to write this binary. This is a binary of decimal 1. This is a binary of decimal 2. Okay, this is a binary of decimal 3. Now I'm telling you how I got these numbers. That I'm telling you. Okay, so if I have to write the binary of 3, how I will get it? The number at this position where I get 1, this should be 1, and number at this position where I will get 1 into 2. Okay, if this is 1, these two numbers are 1. So 1 1 is the binary of 2. Oh, sorry, 1 1 is the binary of 3. Okay, so this 1 1 is the binary of 3, right? If I have to get 4, so 4 means this 2 raised to power 2. This position should be 1. 2 to the 4. So that means this position, third number should be 1. So what I will do here, this should be 1 and these two numbers can be 0 because here I will get 0, here I will get 0 and here I will get 4. So 4 plus 0 plus 1 plus 0 will give me 4. So this is how we get the binary conversion of decimal numbers. Clear? Yes? Am I clear? Yes, this I am telling you how we get these binary numbers for this decimal numbers. So this I see that first position will give me 1, second position if this is 1, this will give me 2, 1 into 2. So this third position is 1, it will give me 1 into 2, 2 raised to power to 4, 1 plus 4. So accordingly I see if I want 6, so I will make this 4 plus this 2, 4 plus 2 6. So what, how I will write 4 plus 2, this position of 4 and this position of 2 should be 1. Then I will get 6. If I want 5, what number I want for 5? 4 plus 1. So that means in this position I get 1. If this is 2 raised to power 0 and 4 plus 1. So this can be 0. So this number will give me 4. This position will give me 4. Third digit. So here 2 raised to power 2. So I know that this will be multiplied by 2 raised to power 0. This will be multiplied by 1. This will be multiplied by 2 raised to power 2. So this will give me 4 plus 1, 5. Yes, you need some practice for this. This is what I'm saying, that if you will practice many times these conversion, then you don't need to memorize, I mean you don't need to calculate this, you can easily memorize these numbers. What is the binary for 5, what is the binary for 6, for 7, if you have practice, no, if you practice it few times. Okay, now I come back to the question which we were doing. We were doing how to convert from binary to octal. So this I told that if you go by long method, first you will convert from binary to decimal, then you will convert from decimal to octal. Okay. But if you want shortcut, you just divide it in group of 3 from right hand side. Then write that 101 is the binary of 5 and 010 is the binary of 2, because in this position, this will be multiplied by 2 raised to power 1. And this 25 we get as the octal conversion of binary. Okay, clear? Next is if I have to convert from octal to binary. This was binary to octal. This is in binary, 010 is binary, and how to convert it into octal. I got 25. Now if I have to convert this 25 octal into binary using shortcut method. So here what I was doing, I was writing this binary. For this binary, I was writing the decimal number for this binary group. Here I have this decimal number and I will write the binary because I have to convert it into binary. So I will write for 5 what is the binary number, 101, and for 2 the binary number is 010 in 3 digits. In octal we will write it in 3 digits and then we will combine these two, so we get the binary of this octal number. Okay, so from binary to octal, write these binary numbers into its decimal. Okay, and from octal to binary, write these numbers, write the binary for this number individually. What is the binary in 3 digits for this number? What is the binary in 3 digits for this number? Suppose we have one more number, so write in a group of 3 digits the binary for this octal. Okay, next is if I have to do binary to hexa. Okay, so from binary to hexa, now for binary to, for binary to octal, what I was doing, I was writing these binary numbers from right hand side in a group of, yes, how I was writing from binary to octal, I was writing the binary number in a group of
Group of 4.
3.
3.
Here I was writing this, dividing this binary number in a group of 3 from the right hand side. 101, then 01, then there is no third number, so we just add 0. From right to left, group of 3. In binary to octal, I will divide this binary in a group of 4 from right to left. Okay, so first group will be 1010. This is first. Then next we have only one. So what I will do, I will add three zeros before it, because we know that if we add zero before this, it will not add any value. So now I have divided this binary into group of 4 from right to left. Okay, so here I know that 101 is the, again you convert this group into its equivalent decimal, which I just showed you. Okay, so this 101 is the binary for 5, and 0001 1 in the first position is the binary for which decimal number? 1. So then combine these two number 1 5. Okay, this is binary to hexa. And what I have to do for hexa to binary? Yes, Norbert, please, what is your doubt? Yes, tell me what do you want to ask.
My problem is the base, like for for hexa, I'm saying it's 15 base.
Your voice is very
So
low,
hexa,
we can't hear you. Your voice is very low.
uh, I was saying the one for hexa, I'm seeing you getting from binary to hexa, it's having like this one of binary is having 1 base of 10, then 5 base of 10, but in hexa it is coming to 15 base 60.
Yes,
So how,
because here for this one, I write one. So here, this is the, for one, what is the binary number? Because there I was having two. In here you are asking, here I was having two. So for two, my binary is 010. Because for two, I have to make this second position one, which will be multiplied by 2 raised to power 1. 2 raised to power 1 is 2. This will give me. But for 1, this first number should be 1. It should be multiplied by 2 raised to power 0. It will give me 1. So that is why obviously, because for 1, this first number should be 1. This is a binary of 1 and this is a binary of 5. So here I was having 25. So binary for 5 is same. Whether you write 010 or whether you write 0101. Because main thing is this 1 1. I have to check the where I will get the value. I will get the value from 1 1 position. 0 will not give me any value. 0 multiplied by anything is 0. So that is why for 5 it is same. But here it is for 2. So I'm making this second position 1. And here it is for 1. So I'm making this first position as 1. I hope that you were asking this thing only. If,
yes.
right?
Now, what about the subscript?
This one.
Mm,
This just
yeah,
shows
yeah.
that which, yeah, this just shows that which number system is this. This was in binary, so in the base I write 2. This is in decimal, so in the base I write 10. Okay, and then this is in, I have converted it into hexa, so that is why here I am writing 16 in the base. So how to convert from binary to hexa? You have to convert it in a group of 4 from right to left. Then you write the equivalent decimal number for this group. The binary, the decimal number is 5, and for this group the decimal number is 1. And when you combine these number, this gives you the hexadecimal number for this binary number. So whatever I'm writing, this is my binary, so writing 2 here. This is my decimal, so I'm writing 10 here in the base. And this is my hexadecimal number, so I'm writing 16 in the subscript, because I have to convert this binary to hexa. So from this binary, so I got this hexa 15. Okay. And
Yes, it's clear.
how to convert from hexa to binary? Again, this suppose this hexa is given, so you have to write what is the binary for this 501. In a 4 digits you have to write. In 3 digits I could write 101, because in hexa I have to write it in digits, so I will add 10 before that. And for 1 I know 0001. In octal I will write it 001, because there I have to write in a group of 3 digits. In hexa I have to write in a group of 4 digits. So you get, first you write the binary of each decimal number, and then you combine these binary numbers. So this gives you the equivalent binary of this hexadecimal number. So this is in hexa, then I write it in decimal, then I write it in binary, then I combine it. So I just change the base from which I come to know that this number is in which number system. Okay,
Yes.
right? So this we did all the number conversions basically. I have sent you my file. I am repeating again. You have to practice it again and again. Only then, no, you will have the confidence. Whether you can do it, you will practice it 10 times. Then you can do it yourself without copying. First, you just see it and do it. Repeat it. And then, without seeing the answer, you can do it if you practice. Okay. Okay, next is we come to some binary mathematics now. Okay, that numbers system conversion is over. Now I know that computer saves all the information in binary form. Okay, 0 1 form. Now how it will add those numbers, binary numbers, how it will subtract those binary numbers, because what we do, we if I say 25 plus 25, it will give me 50. 25 is, this is in which number system I'm doing addition? Which number system is this? If I say 25 plus 25 is equal to 50, that I know I'm adding these number. Which number system is this? I'm adding. Which number system we use? Which number system we use in our daily life? Yes, Abdullahi. When I say 10 plus 20 is equal to 30, which number system is this? This I am asking about what we did yesterday also, Abdullahi. This I told you yesterday also. If I say 123 plus 50, which number system is this? We use binary. When I write 1212, this is binary. When I use 9456, this is binary number system, Francis. In binary, we use only 0 and 1. So we use binary number system. Computer uses which number system? Which number system computer uses and which number system we use? Human beings use. Yes. Computer uses binary, right? I think there is so much network issues in your country. Yes, Francis, is it clear now? Computer uses binary or we uses binary? Yes. Yes, Francis, can you hear me? At least say yes or no. Now, which number system we uses? Yes, which number system we use, Francis? Now you know that binary computer uses binary language number system. That is 0 and 1. Which number system we use, human beings use in our daily life? If I say you need to pay 10,000 rupees, which or you need to pay 2 lakhs, 40,570. Which number system is this? Yes, Francis, you have to reply, please.
Hello. It's decimal number system.
Yes, you took, how long you took to answer me this?
I was
We
trying
use,
to recollect.
yeah, we use decimal number system. Okay. Now the question is, we whatever addition we do, like I was saying, 25 plus 25 is equal to 50. This addition we are doing in decimal number system. Clear?
Yes.
Now, when I give this decimal number system to computer, it will convert it into binary. It will add it into binary, right? Now we know the rules of addition in decimal, but what are the rules for addition in binary? How computer will add these binary numbers? That I am telling you now. Okay, binary mathematics. How it adds in binary, how it subtracts in binary. Clear?
Yes, clear.
Now, what is the binary rule of binary addition? 0 plus 0. Answer is 0 and there is no carry. 0 plus 1 is 1 and no carry. 1 plus 0, because obviously in binary there will be only 0 and 1. So if it is 1 plus 0, again the result is 1 and no carry. But if both digits are 1, 1 plus 1, result is 0 and carry is 1. Okay, like if I say 5 plus 5, I will write 0 and carry 1 in the next column, right? Same way, if this is 1 plus 1, this will give you answer 0 and carry is 1. Clear? This is the rule of binary addition. Clear, Francis?
No, come again.
0 plus 0 is 0, no carry. 0 plus 1 is 1, no carry. 1 plus 0 is 1, no carry. And 1 plus 1 will give you 0 and carry 1. We carry forward na, and in normal math when I say 17 plus 33, so what I will do, 7 plus 3 10, and next column 1 will carry in the next column. Yes, Norbert, please. Your network got disconnected.
Yes,
So you answered right that computer uses binary. Now which number system we use, human beings?
we use decimal.
Very good. So now I was telling you that we know the rule how to add in decimal number system, how to subtract, because that we have learned in mathematics in class 1 2, right? Now we have to see that how computer adds in binary numbers, because whatever decimal number I will provide, the computer will convert it into binary. So now how addition is done using binary number system, how subtraction is done in binary number system, that we will see here. Binary mathematics. Okay. So now Francis, can you explain how we do binary addition? Because they both left because of the network issue. Now, Francis, you explain them this binary addition.
Yeah, so when we have 0 plus 0, the result will give us 0 and no carry. And then 0 plus 1, it gives us 1. and then 1 plus 0, it will give us 1. And then 1 plus 1, it will give us 0.
You're
And
not.
carry is 1.
Yes, carry is 1. This is the main thing, right? 0 plus 0, answer is 0, no carry. 0 plus 1, answer is 1, no carry. 1 plus 0, answer is 1, no carry. But if 1 plus 1, then answer is 0 and carry 1. Obviously, because when we are working with binary, so it will have only 0 and 1. Okay, and like we do 7 plus 3, 10. So I will write 0 and carry will be 1. Same way, if there are both numbers are 1, then answer will be 0 and carry will be 1. Clear? Norbert Peace and Abdullahi, both of you. This is the
Yes. Clear.
addition of two binary numbers. Now, how to do the addition of three binary digits? So, in that case, what is the rule? 000 is sum 0, no carry. 001 is sum 1, no carry. 010 is 1, no carry. 1011, if there are two ones, that means like we have done here, if there are two ones, that means answer is 1 and carry. Answer is 0 and carry is 1. So same way, if there are two ones, answer is 0 and carry is 1. Okay, if this is 100, 1, no carry. 101, again there are two ones, so 1 plus 1 is 0 and carry is 1. Right? 110, two ones are there, so 1 plus 1 is 0 and carry 1. If all three are 1, then answer is also 1 and carry is also 1. This is the rule of binary addition with two digits and with three digits. Clear? Yes.
Yes.
Yes, clear.
Next, this is the example I have done. Suppose if I have to write given these two numbers, so how I will write the addition? 0 plus 1 is 1, 1 plus 0 is 1. So I can check whether my answer is correct or not. I will write that this is the binary number of 2 and this is the binary number of 1. So 2 plus 1 is 3 in my decimal system, and whether this 1 and 1, this is also the binary of 3. So that means my answer is correct. I can convert it into decimal and then I can check whether my answer is correct or not. Now we will see the rule for binary subtraction. Okay, so what is the rule? 00 is answer 0, no borrow. Now what we do, if I say that 13 minus 7, 113 minus 7, so obviously you cannot subtract 7 from 13, 3. So what you will do, you borrow 1 from the next column, from the next digit. Getting it? In decimal, this is what we do. If you have written 23 minus 7, so 7 cannot be subtracted from 3. So you will take 1 from 2. And then it will become 13. And then you will write 13 minus 7. Same way, you have to subtract 1 from 0. So obviously, answer will be 1 and it will borrow 1. It will borrow 1. Because obviously, 1 cannot be subtracted from 0. Big number cannot be subtracted. So there will be 1 borrow. 1 minus 0 is 1, no borrow. And 1 minus 1 is 0, no borrow. Okay, so in addition we see sum and result. In subtraction we see result and borrow with two digits. So here 1 minus 1 is 0, 1 minus 0 is 1. And then I can check my answer if I convert it into decimal. Clear? How to do binary subtraction and binary addition? Yes. Next is complementary. Yes, Francis, tell me.
I would like to know the difference why we use borrow and carry.
Now see, if I show you this numerical, then you will understand this. Suppose this is my, if I am given that 1010, subtract 101 from 1010. Okay. Now this, yes. Now this one I cannot subtract from 0. So what I will do? I will borrow 1 from here. Okay. Then it, in decimal it becomes 10, because decimal the base is 10. But in binary, when I borrow 1, it becomes 2, because in binary the base is 2. So when I borrow 1 from the next column, it will become 2. So 2 minus 1 is 1. Okay. Now here it is left 0. 0 minus 0 is 0. Again I cannot subtract 1 from 0. So again it will take borrow from the next column, and it will become 2, not 10. Because when we do in decimal, it becomes 10. But in binary, it becomes 2. So 2 minus 1 is 1. And then this is 0. So I hope I have shown you one more example of subtraction. Francis,
Yes, clear.
clear? So this is your binary addition. Now your next topic is complement, how to calculate the complements. Okay. If you have to write the ones complement of any binary number, what you have to do, you have to simply write 1, you have to just reverse it. Write 1 in place of 0 and write 0 in place of 1. That's it. Okay. So if I have to write the ones complement of 101, so here what I will do, in place of 1 I will write 0, in place of 0 I will write 1, in place of 1 I will write 0. So you have to change 1 to 0 and 0 to 1. That this is the ones complement of this. If you have to write the ones complement of this, how you will calculate it? Tell me. What will be the ones complement of 1011?
We replace the ones with the zeros and
Very good.
zeros with ones.
Yes, and you will get 0100. Okay. So any number, if you have to write the ones complement. Next is how to find the two's complement. Then what you have to do for finding the two's complement, you have to convert it into ones complement and then plus 1. This will give you the two's complement. Suppose this is 101. So first I will write its ones complement. This will be 0, 1, 0. Then I will add 1 to it. So 0 plus 1 is 1, then 1, then 0. Like we do in binary addition. So this gives you the two's complement. Clear? Don't worry, after finishing this topic, I will give you few numericals for practice. I will do some numericals for practice in the class. First, I'm completing this topic, then we will practice it. So, what you have to do for two's complement, Francis?
For two's complement, we first deal with the ones complement by replacing the zeros with 1 and the ones with the zeros, and then we add plus 1
Very good.
to make the
Very
two
good.
complements.
Right. Right. Okay. This was another topic. Now, next topic is coding scheme. What is coding scheme? As I said, whichever letter you type, whichever number or symbol you type on the keyboard, internally it is saved in some 0 1 combination. Right? Now, how that 0 1 combination are made? Okay, so there are different coding schemes for that. Okay, so now I'm telling you those coding schemes. So first is BCD, binary coded decimal. That binary coded decimal is 4-bit code. It will use 4 bits. Like I showed you, you can write using 3 bits also. You can write using 4 bits. So this will use using 4 bits. And here if you have to write 9, what you will do? For 9, what should be there? 8 plus 1. 2 raised to power 3, 0, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. So this number should be 1. It will give me 2 raised to power 3, 8 plus 1. So this position, 2 raised to power 0. These two numbers should be 1. So this will give me 9. Okay. So this is just like we did simple binary into decimal. Right. So this is that. The only thing is that it uses 4-bit code. Now, what is wrong with 4-bit code? This was the oldest coding scheme. Okay. So, what was the issue for that? 4 bits means 2 raised to power 4. How many combinations? 2 to the 4, to the 8, to the 16. That means only 16 unique codes can be written using 4 bits, because for every character, every symbol, you need a unique code of 0 and 1. But if you are using 4 bits only, then using 4 bits you can make only 16 unique combinations. For 2 raised to 4, 2 raised to power 4 is 16 combinations you can create. But that is not enough, because 0 to 9 we have 10 numbers, and how many alphabets we have? A to Z 26. So this will 16 will not cover my basic alphabets and number even. Okay, so this was not sufficient. So it was made 6-bit code. 6-bit code means 2 raised to power 6. How many combinations can be created? 2 to the 4, 2 1 the 2, 2 to the 4, 4 to the 8, 16, 32, 64. 2 raised to power 6 is 64. So we could create 64 combinations, unique combinations of 0 and 1, if we are using 6-bit code to represent our decimal number, because I know that we will write in decimal and computer will convert it into binary. If computer is using 6 bits, then it can have 64 unique combinations. Now again we will see 26 for small abcd, 26 for capital abcd. This is 52. And then we have 10 numbers, the 10 digits 0 to 9. Okay, so this is 62 and it has only 64 combinations. Okay, now number and digits are covered. But now what about all other characters on the keyboard? Open bracket, close bracket, star, greater than sign, comma, all this. Because as I said, whichever key we press, it has a unique code of 0 and 1 internally. For us, this is A, B, C, D, but for computer, it has a special code of 0 and 1. So, if it has only 64 combinations, it won't be having any combinations left for all other symbols on the keyboard. It can only give combinations to numbers and digits. So, again, this was not sufficient BCD. Okay, so it was improvised and then they made it EBCDIC, this coding scheme, extended binary coded decimal interchange code. It started using 8 bits. To represent, you have to represent every number or digits in 8 bits of 0 and 1 code. Okay, now we calculate 8 bits. 2 raised to power 8 is 256. Now it's sufficient. We can give the unique 0 and 1 code to computer, can give to small a to z, capital A to z, 10 digits, then all other characters on the keyboard can be easily covered. Okay, so each character on the keyboard will get a unique 0 and 1 combination. If we represent it using 8 bits, then it can have 256 combinations. Fine, this was sufficient. Okay, So this was used by IBM machines, IBM computers. Next is ASCII, American Standard Code Information Interchange. That earlier version was using 7-bit code that could have 128 characters, and 8-bit code in ASCII could have again 256 combinations. So IBM machines was using this EBCDIC code, and American machines were using this ASCII coding. This was American standard. Okay, but both were giving me 256 combinations, right? But nowadays, this is also not sufficient. You know why? Anyone? Now, this 8 bits, 256 combinations are not sufficient. Tell me why? हेलो। अंकल वो भैया आए थे कल कलेक्शन के लिए, उससे बात करनी थी, ये सेक्टर 22 में। Yes, this is not sufficient because I mean this is sufficient for English alphabets and numbers, but nowadays we use the keyboards in regional languages also, right? For different languages, you have different keyboards. So now in 256, all the alphabets of your regional language of all over the world, so many languages like Japanese, Chinese, nowadays everyone has their own language keyboard. So that cannot be covered in 256. So we have some latest coding scheme for that. So I would appreciate if you are able to find out what is the latest coding scheme is used nowadays by the computers. This is your homework. Okay. Now we'll do some practice of numericals, and then in the next class I will start with the new term. Okay. Now I'm giving you some numericals for practice. Clear all of you? Should I stop this file here? Nobody replies. add these two numbers. First, we do the practice of binary mathematics that we covered today. Add 0, 1 and 1, 1. Tell me what is the answer. Yes, what is the answer? Yes, Francis, tell me.
So using addition,
Yes,
uh,
binary
z-
addition. Yes.
yeah, 0 1 0 1. The result is 1 and carry no carry.
No, just tell me the
Uh,
answer. What is the answer?
so it's 1 and 0.
No. Answer is anybody else? Sorry. Sorry. Just let me see what will be the answer. What I gave you 0, 1 and just a second. Just a second. 0, 1 and 1, 1. 1, 1, 0, carry 1, 1, 1, 0, carry 1. 0, 1 and 1, 1. Yes, what is the answer? No, this is wrong, Norbert, please. Answer will be, what was your answer, Francis?
My answer was 1 0.
100 will be the answer. because for the first 1 1 answer will be 0 and carry 1. Then in the next column this is 1 1, again 0 and carry 1, and in the next column carry 1 will be written. So this 100 will be the answer. Okay, and in decimal also we can see that this 1 1 is the binary of 3, this 0 1 is the binary of 1, so 3 plus 1 4, and this 100 is the binary of 4. So that means my answer is correct. Yes, you can correct this, Francis and Norbert Peace. Did you get it?
And we did
Yeah,
see a screen.
100 will be the answer. Yes, Norbert.
yeah, I got it.
Okay. Now try 0 1 and 1. I'm giving you very simple numbers, I'm not giving you difficult ones. Add 0 1 and 1 0. 0 1 and 1 0. Yes, Abdullahi. Binary addition. Can you do it? 0 1 and 1 0. What will be the answer?
1 1.
Yes, right. 1 1. Good. Now you got it. Yes, right, Abdullahi. Right. You got it. Okay. So addition is, I think you are able to do it. Now do some problem of subtraction. So subtract 0 1 from 1 1. Subtract 0 1 from 1 1.
1 0.
Oh yes, very quick. Your answer is correct. Okay, 1 0. This is right. And I think now you are telling me, Francis, for, oh yes, for addition. For this question, what is your answer? Subtraction, Francis? Francis and Abdullahi. Tell me the answer for this subtraction. What happened?
It's 1 0.
Yes, right. Abdullahi? Yes. Okay. So now you know how to do the binary addition and binary subtraction, right? Now we can do some practice of complements. Okay. Now tell me the two's complement of 101. Tell me the two's complement of 101.
It's 011.
Yes, correct. Norbert Peace and Abdullahi.
Well, I couldn't calculate it.
Sorry.
I failed to calculate. Maybe let Francis explain to us.
Okay. So first you have to convert it into one's complement. How to convert it into one's complement? Yes, Francis, what you are supposed to do? Just write 1 in place
How?
of 0. Yes.
Yes.
And 0 in place of 1. So for 1 0 we know I will write 0 1 0. This will be the
And
ones
add
complement. And then
and add one.
add 1. Yes, if you add 1 to this, so you will get 0 plus
Zero
1.
one one.
It's 0 plus 1 1. Then this is 1. Then this is 0. First convert it into ones complement, then add 1. Clear, Abdullahi and Norbert, please? Write the ones complement, then add 1 to its ones complement.
No,
What you're not getting in this?
converting it.
Sorry?
The part of converting it
Tell
one's
me the
complement.
tell me the ones complement of 1011. 1011. Tell me the ones complement. Tell me the ones complement.
It's zero
No,
one zero zero.
Norbert please will tell me. Norbert please and Abdullahi will tell me the ones complement of this number. What is the mistake, Francis, in this? Tell him.
So it's like this. You you replace the zero with the one, and then the one with the zero to make the ones complement.
Abdullahi, there is some mistake in your answer. Do it again. Complete it.
I'm on the seat.
Complete this. This is not complete. Abdullahi, complete this. Write the complete answer. What you are writing? This one's complement or two's complement? Just tell me the one's complement of this number. Abdullahi, now this is right. Method is right. 100 plus 1. I'm just asking you, tell me the ones complement first. I'm not getting whether you're telling me the ones complement or the twos complement. First, you clear it. What will be its ones complement? And Norbert, please, what you are doing, tell me ones complement or twos complement. First, you tell me what you are telling. I'm just saying, tell me the ones complement. That's it.
The ones complement.
This is ones complement.
Yeah.
Francis, tell them again what will be the ones complement of 100.
You mean 100? The one's complement of 100 is 011.
Type it in the chat box. Write the yes. What this is one's complement. Now, how I will calculate the two's complement? Write that in the chat box. Is it clear, both of you, Norbert, please, and Abdullahi? What is one's
Yeah.
complement? Now tell. Now write the two's complement, Francis. No, Francis, 1 plus 1 is not 2 in this binary. This is for our decimal. 1 plus 1 is what in binary addition? Add 011 plus 1. Like you just did the binary addition now. 1 plus 1 is 0, carry 1. Then it will go to the next column. Then again 1 plus 1 will be 0. Again carry will go to the next left column. Here it is 0. So 1 plus 0 is 1. first 1 plus 1 is 0, carry 1. Then again in the next column 1 and plus carry 1 is 0. Then again carry in the next column 0 plus 1 is 1. Yes, yes, right. Now tell me the two's complement of this number 1011. Yes, right, Norbert, please. This is correct. Now you got it. Okay. What about others? Are you getting this answer or not? Yes, right, Francis. Abdullahi, what is your answer? Abdullahi, are you doing it?
Yes. Change 0 to 1, 1 to 0. When you complete, add 1 to the end.
I can't understand you clearly. Just tell me whether you got this answer or not. Abdullahi, should I wait or you have done now? Yes, right. So now all you did the practice of binary arithmetic and complement number. Now please practice those number system, how to convert from one number system to another. I have sent one file of practice numericals also. Okay, there in that file I have given numericals just for your practice. I hope all of you received that mail from Martin. All of you received those notes from Martin. Okay, good. Abdullahi, you exchange your email ID so that he can send you. Francis, you can take his email ID or you can take yours. Norbert, please, did you receive the mail notes?
Yes, I got it.
Okay. So, are you giving your mail ID or should I disconnect? Right, Francis? You can give your mail ID also to Ibrahim. He will send you a mail.